Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the instruction set of 8051 microcontroller. In that video, we have seen the program branch group instruction. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the Boolean group instruction. This group of instructions manipulates individual bits without affecting the other bits of the word. That means these instructions are operated over a single bit. A particular bit is set or reset. We know that if we want to set a bit, that means we want to make it 1. If we want to reset bit, then we simply 0 provide 0 to it. Okay, these instructions performs the move, set, clear, complement or and operations on a bit or a carry flag. The bit addressable RAM area and SFRs are assessed by using these instructions. There are number of bit addressable instructions such as and, or, complement, clear, set, reset. Let's see one by one. The first instruction is ANL. ANL stands for AND logic. Remember here that this AND logic is performed on a single bit, not on a total byte. Okay. Its syntax is ANL C, source bit. That means logical AND for bit variable. Flag is carry flag. The carry flag is ANDed with the source bit and the result is stored in carry flag. That means in this instruction this source bit is ANDed with the carry flag. And operation means multiplication operation, and we know that 0 into 0 is equal to 0, 0 into 1 is equal to 0, 1 into 0 is equal to 0, 1 into 1 is equal to 1. Okay, that means if both the inputs have the value 1, then and then the output is 1. Okay, this is the AND operation. For example, ANL C, ACC dot 7, that means accumulator 7 bit is ANDed with the carry flag and the result is stored in the carry flag. Similarly, in next example, PSW dot 1 bit is ANDed with the carry flag. I hope you all understand the AND logic. The next instruction is ANL C, complement of source bit. The function is logical AND and complement for the bit variable. The carry flag is ANDed with the complement of the source bit and the result is stored in the carry flag. For example, ANL C, complement of P1.0. That means if the P1.0 bit is 0, then first it is complemented, and we know that the complement of 0 is 1. That means the bit is first complemented and then ANDed with the carry flag. Whatever the result of the AND operation is stored in this carry flag. Okay. The next instruction is ORL, that means OR instruction. We know that OR means the addition, and the rules for the addition is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is also 1. That means if any of the input is 1, then the result is 1. This is the OR operation. Its syntax is ORL C, source bit. That means this source bit is ORed with this carry flag and the result of the OR operation is stored in the carry bit position. The carry flag is ORed with the source bit and result is stored in carry flag. For example, ORL C, P1.7, ORL C, PSW.1. Okay. The next instruction is ORL C, complement of source bit, logical OR and complement for bit variable. The carry flag is ORed with the complement of the source bit and the result is stored in carry flag. For example, ORL C comma complement of P1.0. That means whatever the value having the P1.0 bit is first complemented and then ORed with this carry flag. Whatever the result of this addition is stored in the carry flag. I hope you all understand this instruction. The next instruction is move. The move instruction is used to copy or to load the data, but remember here this move operation is performed on a single bit, not on a whole byte. Okay, its function is move bit variable, move source bit to the destination bit. It copies source bit to the destination bit. One operand must be carry flag. The very important condition here that its one operand must be carry flag. That means the destination bit or the source bit must be carry flag. For example, move C comma PSW dot 3. That means whatever the data or whatever the value of the PSW 3 bit have is copied or is moved in the carry flag. The next instruction is CLR. CLR stands for clear. Its syntax is CLR bit. That means clear bit. It clears a single bit. For example, CLRC, that means after the execution of this bit, carry flag has the value 0. Next, CLR P1.6, after execution of this instruction, the P1.6 bit has the value 0. Clear means make it 0. I hope you all understand. The next instruction is SETB. SETB stands for set bit. Its syntax is set bit comma bit. Okay. It sets a single bit. Bit sets means its value becomes 1. For example, set bit C. After execution of this instruction, the carry flag has the value 1. Or set bit P1.6. After execution of this instruction, the P1.6 has the value 1. The next instruction is CPL. CPL stands for complement. Its syntax is CPL bit. Okay, it complements a single bit. That means, for example, CPLC. If carry flag has the value 0, then after this instruction CPLC, its complement is C is equal to 1. Okay. The next instruction is CPL P1.6. After execution of this instruction, the P1.6 bit is get complemented. That means whatever its value has, if it is value has the 0, then it is complemented to 1. If it has the value 1, then it is complemented to 0. The next instruction is JB. JB stands for jump if bit is set. Okay, if bit is set, then jump to the relative address. If the indicated bit is 1, then jump to the relative address. Otherwise, proceed with the next instruction, and we know that the relative address is within minus 128 to plus 127. For example, JB P1.5 here. That means after the execution of this instruction, if P1.5 if P1.5 has the value 1, then jump to here. If this P1.5 has the value 0, then there is no need to jump this area. The next instruction is proceeded. I hope you all understand. The next instruction is JNB. JNB stands for jump if bit is not set. If bit is not set, then jump to this relative address. If the indicated bit is 0, then jump to the relative address. Otherwise, proceed with the next instruction. And we know that the relative address range is within minus 128 to plus 127. For example, JNB P1.5 comma here. That means after the execution of this instruction, if P1.5 bit has the value 0, then and then jump to here. If this bit has the value 1, then proceed with the regular instruction. The next instruction is JBC. JBC stands for jump if bit is set and clear bit. That means this bit is set, then jump to the relative address and then clear this bit. If the indicated bit is 1, then jump to the relative address and clear it to 0. Otherwise, proceed with the next instruction. Its example is JBC P1.5 comma here. That means after the execution of this instruction, if P1.5 is has the value 1, then jump to here and during this process clear this bit. That means during this process make it again P1.5 0. Okay. The next instruction is JC. That means jump if carry is 1. If carry is 1, then jump to this relative address. It examines the carry flag. If the carry flag is 1, then jump to the relative address. Otherwise, proceed with the next instruction. For example, JC next. If the carry flag has the value 1, then jump to the next address or the next area. Okay. The next instruction is JNC. That means jump if no carry or jump if the carry has the value 0. It examines the carry flag. If the carry is 0, then jump to the relative address. Otherwise, proceed with the next instruction. Its example is JNC next. That means if the carry flag has the value 0, then jump to this address. I hope you all understand the Boolean group instructions. Our next point is assembly directives of assembly language programming. In assembly language programming, there are number of assembler directives, that means such as org, that means origin, db, define byte, equate, and end directive. Let's see the details of each directive one by one. The first directive is define byte or db. The db directive is most widely used data directive in the assembler. It is used to define 8-bit data. That means whatever the byte used in our program, this byte should be defined first. Okay. When the db is used to define data, the numbers can be in decimal, binary, hexadecimal, or in ASCII formats. Programmer has to mention binary, H for hexadecimal, mention binary and hex numbers. Regardless of which is used, assembler will convert these numbers into hex. To indicate ASCII character must be written in quotation mark. For example, hello. Okay. When we write, when we want to give a binary value, then we have to write B. If we want to give hexadecimal value, then we have to write H. And if we want to write an ASCII character, then it should be in the quotation mark. Okay. Like that. The assembler will assign the ASCII code for the numbers for the character automatically. The define byte directive is the only directive that can be used to define ASCII string larger than 2 characters. Therefore, it should be used for all data ASCII definitions. The next directive is org, that means origin. The org directive is used to indicate the beginning of the address. That means when we start our program, then we can select the memory location for the program. This memory location or the beginning of the program is shown by this origin address. Okay, the number that comes after org can be either in hex or in decimal. That means if org 00 is given, then we have to write here h. That means at the 00h memory location our program is start. If the number is not followed by h, then it is decimal and the assembler will convert it into hex. Some assembler uses .org instead of org. The next assembler directive is equate. This is used to define a constant without occupying a memory location. The equate directive does not set aside storage for a data item but associates a constant value with a data label so that when the label appears in the program, constant value will be substituted for a label. The following uses equity for the counter constant and then the constant is used to load the R3 register. That means constant equate 25h. Okay, move a comma constant. After the execution of this instruction, constant equate 25h. That means this constant has now value 25h. Okay. Then move a comma immediate constant. The constant has the value now 25h. This 25h value now loads into the accumulator. Hence, after the execution of this instruction, the accumulator has the value 25h. Okay, and the last assembler directive is end. This indicates to the assembler the end of the source or the ASM file. The end directive is the last line of the 8051 program, that is in the source code. Anything after end directive is ignored by the assembler. Some assemblers use .end instead of end. That means if we give the end directive after the program, then after this end any instruction is written, then these instructions are not executed. Okay, I hope you all understand all the assembler directives used in the 8051 assembly language programming. Thank you.